At an amusement park, there's a roller coaster where some people get on here and they roll down and over this hill here. First question is, what's the speed at point B? This question here, you've got to equate and say, at the top, what sort of energy have they got? They've got gravitational potential energy. And when it gets down here, that turns into kinetic energy. So the gravitational potential energy at the top equals the kinetic energy at the bottom. So let's work out what that gravitational potential energy is, because it's equal to mgh, which is, the mass is, what is the mass? We've got total mass of 1000 kgs, that's m, and 20 kgs is the, 20 meters, sorry, is the height. So we've got 1000 times gravity is 10 times 20, that equals 200,000 joules. And that turns into the kinetic energy. So kinetic energy equals 200,000 joules, and we know kinetic energy equals a half mv squared. So we have to rearrange to find v. So times both sides by 2 and divide by m, we get v squared equals 2 times 200,000 divided by the mass, which equals 400,000 divided by 1000, which equals 400, and it's v squared. So v, it must be equal to 20. Alright, from point B, the car then travels up the slope at point C. So they come down, and they go up again. This is B, A, and C. At point C, the track is part of a vertical circle of radius 10. Radius equals 10. At this point, the riders in the car feel as if they have no weight. Rebecca says they are not actually weightless. Explain why Rebecca's statement is either correct or incorrect. Well, no, there's still gravity there, so they certainly are not actually weightless. So Rebecca is correct. They are not actually weightless. Right, so they feel weightless at that point. Because for someone to feel weightless at that point, there has to be no normal force on them. So this is the point C. There's gravity acting down. Because this is going around this circle, and there needs to be a total force, centripetal force, or going towards the centre. In this case, there's no normal force. We'll work through this one a bit clearer in the next question. But there's no normal force, and that's why they feel weightless. They feel weightless at this point because there is no normal force. And just to clarify that, the gravity force equals centripetal force. What must be the speed of the car at point C for the riders to feel as if they have no weight? Okay, for them to feel as if they have no weight, they have the gravity force acting down on them, and that equals the total force, which in a circle is the centripetal force. Centripetal force. Writing that out, the gravity force downwards equals the total force, which is mv squared over r. Okay, gravity force is the total force, and it's also the centripetal force, so it's mv squared over r. So we have to find what v is in this case. So mv squared over r equals mg. M's cancel out. we have v squared over r equals g, v squared equals gr, v equals the square root of gr. So square root of 10 times, and what is the radius? Vertical radius of 10 meters. 10, which equals 10.